Hello and welcome to this video on least common multiple and greatest common factor. It's meant to kind of be a review and a refresher. You should have some experience with least common multiple and greatest common factor. Okay. At some point I'll use my calculator a little bit, but this is mostly meant to be a mental approach, number sense and feel approach, but calculator is always a good tool, so I'll have it handy. So, one of the things I want to touch on is that when people do LCM and GCF, they get them confused with each other. It makes sense to me that they do. Maybe I'll touch on that in a couple minutes as to why. Try and keep the video short though. So, least common multiple. Let me give you a quick translation how I see that in my mind. L for least, which I'll just call smallest. Okay. C for common, which I'll call shared. Okay. And multiple, which I'll call count by. Okay. So, smallest needs no explanation. Shared. Well, shared means it's appearing in all lists generated by all given numbers. So, just quickly, if I have like 5 and 6, okay, the count bys of 5 generate the multiples of 5. 5, 10, 15, 20, 25, etc., etc. These are the count bys. When you count by 5, you get multiples. Little nickname I have for them. Then counting by 6, you get 6, 12, 18, 24, etc., etc. These lists are infinite as well, as pretty obvious, right? Okay, shared just means it would appear in both lists. Okay, I don't have anything here that appears in both lists. If I kept going, you'd see I would get 30 on the next hit, right? Okay, so 30 would be something that's common in both lists. Okay, so smallest shared count by is translation for LCM. Okay, and here I'll get into examples more so in a second, but you see the smallest number that appears in both lists here is 30. So the LCM of 5 and 6 is 30. Okay, so GCF, greatest common factor, P for greatest, which will translate to biggest, not a shock. Common again is shared, which means it's amongst all the given numbers, and factor is a divisor. Okay, like 4 is a factor of 12 because 4 goes into 12. Little joke from my physics teacher in college, high school, excuse me. 4 goes into 12, so 4 is a factor of 12. Okay, because it's also a divisor. Okay, I guess you figured out that this goes into is this kind of slang for goes into. Okay, but it's a factor or a divisor. Now, just real quickly, I'll try and touch on why people get these backwards. Okay, least common multiple. Well, you know when I did the multiples, the numbers got bigger, but you're using the word least. So I think that gets people confused. Similarly, if I talked about the factors of something, like the factors of 8, I would get 1 and 8 and 2 and 4, right? Okay, well, the factors of a number are smaller than the given number, or no bigger than it at least. But then you hear the word greatest, and that throws you off. Okay? That's a quick little explanation why I think people get them backwards. Okay? So let's actually get into doing some examples. I'm going to give you 3 methods for each, if I can. Okay? So, why? Because you need to be fluent, and sometimes when you're given numbers of a certain size, one method is more appropriate than another. So the list method for LCM, when we got what is the LCM of 8 and 12 is what I'll start with, and I'll go into the mental method. A little bit hard to explain without writing, so I'll try and write what I'm thinking at least. And then prime factors is a very formal method. So the list method, we just list out the multiples by counting off by the numbers. 8, 16, 24, 32, 40. Now the list can go forever, so sometimes this isn't a great method. So now let's do 12, 24, ding, ding, ding in the back of my head, 36, 48, can go forever. Now, you should look in both these lists and say, there's a number that appears in both of them, and the smallest one that does is 24. So it is the least smallest common, shared by both lists. Multiple, well, that's what these lists are. They're the count bys. Okay, so the answer here is just 24. It's going to be 24 all 3 times after. So, okay, so mentally, what do I do if I'm doing it mentally? Well, I just kind of take the bigger number and count by that and say, is the other number a factor of the numbers that I'm generating? So I'll count by 12. So here we go. 12. Is 8 a factor of 12? No. 24. Is 8 a factor of 24? Yeah, we're done. You might want to replay that because it happened so quickly. The the mental way is a great way to do it if you have a command of it. It's a great way to do it as long as the numbers are small, though, because it's not easy to count by something like 132, which you could be asked, to use as one of the numbers to find the LCM for. Okay, prime factors now. This is a very formal method. So if I did the prime factors, 8 and 12, I'd get 2 and 4, and the 4 would become 2 and 2. So this is 2 cubed. Okay, and then for 12, I'd get 2 and 6, then 2 and 3. Factor trees you can be made quickly, but then you have to be able to ask this question. Okay, for each factor that appears, who has the greatest number of them? And when you find that, steal them out and build a new number. What's that mean? Probably easier done than said. Okay, so I see a factor of 2 in both. Who has the most 2's? Well, the 8 does, so I'm going to steal all 3 of them versus the 2 and the 12. And I see a 3, right? So I'm going to steal out the 3. This one has 1 3. This guy over here, 8, has no 3's. Okay, so what's this when you multiply it together? 24. Okay, so there's 3 methods for finding LCM. I'm going to do them again, but a different set of numbers. You notice the numbers are bigger here. What's the LCM? 24, 36, and 96. Okay? I'm actually going to employ my calculator because I can't count off by 24 so easily. So how am I going to do that? 24, enter, plus 24, and then hit enter a couple times. Okay? I just want to put this so that my calculator is always in front. Okay, so what does that give me? 24, 72, 96, 120, okay? A couple more, 144, 168, 168, 192. Now, I don't really know when to stop because I haven't gotten a chance to look at my other numbers yet. 216, 240, 264. I hope you feel that this is a little inefficient. And 288, and I kind of run out of paper here a little bit. I could keep going. It's an infinite list. Okay? Now, I'll do the same for 36. Now, because 36 is a bigger number, it'll grow a little more quickly, and maybe I'll won't have to hit the button as much. So we got 36, 72, 108. 36, 72, 108. Okay? I see 72 on my other list. That's cool. 144, 180, 216. 144. Oh, I see that one on the other list. 216. Sorry, got to squeeze a 180 in there. Okay. You got 252, 288. Okay. And then I'll go just one more and get 324. Okay. It's a good time to tell you that I am cheating a little because I already know the answer, so it makes my decision making kind of go a little bit more quickly. So now I got 96. So how do I generate the recursive sequence per se of starting at 96 and adding 96? You got 96 plus 96, right? Okay. That's going to give me what? 96, 192, 288, 384. This list is getting bigger faster because I'm counting by 96s. 480. Well, quick look and a scan, you'll see there's 288 in this one, 288 in this one, and 288 in this one. Okay? So, the answer is obviously 288. Not easy to come up with that list method. You got to be patient and organized. Mentally, I guess, what's the deal here? Well, this is kind of hard. Is to ask yourself when you're counting off by this 96 list, are the other numbers factors of it? Well, 36 doesn't go into 96, so I'm done there. 192, does 36 go into that? Well, let's see. 192 divided by 36. Oh, I'm sorry. Wrong device. Sorry about that. Just gonna pull up my calculator. So now we got what? 192 divided by 36. It doesn't. Okay, next thing on the list is 288 divided by 36. And it does. And then is 288 divisible by 24? And it is. So, believe it or not, you would wind up with 288 being the winner. Okay? That's a little work too. I'm going to do this by prime factors now. Okay? And hopefully you'll see this come out nicely. Okay, bigger numbers, prime factors is the way to go, I think. 24, 36, 96. Okay, so for 24, you get 3 and 8. And I hope you guys don't mind me doing 2, 2, and 2 for 8 real quickly. You should have a sense that 8's 2 cubed. Now you got what? 2 and 18, 36, 2 and 9, and then you got 3 and 3. 96, I'll start with 3 and get 32, and then 4 and 8, and then that's going to give me 2 2's here for 4, okay, and then 3 2's when I break the 8. Okay, same question. Who's got the greatest number of a certain factor? So for 2's, we have 3 here for the 24, 2 here for the 36, but 5 for the 96, so that's 2 to the 5th. Now look for your greatest number of 3's. You get 1 3 here, 2 3's here, and 1 3 there. So that's going to be 2 of them to steal out. So what does that become? It becomes, okay, 2 times 2 times 2 times 2 times 2 to the 5th times 3 times 3. Forgive me for not using the exponent button there, but just to give you an idea of it. There you go, 288. Kind of a brute force method. Not a lot to think about. I like the fact that you're taking big numbers using factor trees to make them smaller. But then that question in the end of who's got the most of a certain factor for every factor that appears. Okay? So probably a better way to express that question. If it weren't so late at night, I'd probably be giving you a better idea of it. Okay, so now, that being said, let's take a look at GCF. Okay. Oh, excuse me. I think I just went back too far. Okay, so what's GCF of 8 and 12? Well, there's the list method, okay? The list method is not listing out the count bys, it's listing out the divisors. So for 8, it's 1 and 8, and then 2 and 4. For 12, factors are 1 and 12, 2 and 6, 3 and 4. Okay? Not too long to do because small numbers have few factors. And I guess the greatest common factor, well, this one says 8, and this list doesn't, but this one says 4, and this one does too. That's the biggest number in both lists. Biggest, greatest, common in both lists are shared, factor, divisor, or gazinta. 4, gazinta, 8, and 12. So the answer is 4. Okay, for mentally now, this is kind of what I do. Okay? Before when I did least common factor, I worked with the biggest number. Excuse me, least common multiple, I worked with the bigger number. Now with greatest common factor, I'm going to work with the smaller, which is 8. When I say does 8 go into 12? No. Then work backwards to the factors of 8. 4. Does 4 go into 12? Yeah, you're done. Okay? Now for prime factors like 8 and 12, if you did this, you would get 2 cubed. Okay? And for 12, you would get 2 and 6, and 2 and 3. Now, a little different question than LCM, right? First off, you have to have the factor appear in both lists, and you have to get the smaller amount of them. Okay? So, before, you were getting any number that appeared in either list, and you were getting the greatest number of them. Which, if you notice, it's a little backwards, too. For greatest, we're looking for the least, and for least, you're looking for the greatest number appeared. Okay, so well, I have a 2. I'm examining 2. And who's got the fewer amount of 2's? 12. So 2 squared. Now, here you have 1 3, and here you have no 3's. So you should steal the fewer amount, which is 0 3. So I'm not going to take any 3's. So the answer is 4. Okay? So it takes a little practice. Okay? Let's try and do this for bigger numbers. What's the GCF of 24, 36, and 96? Well, if I did the list method, for 24, I get 1 and 24, 2 and 12, 3 and 8, 4 and 6. Bigger numbers have bigger lists. For 1 and 36, you get 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, right? Okay, let me see if I can fit the 96 in here nicely. So for 96, you get 1 and 96, 2 and 48, 3 and 32, 4 and, well, 4 goes into 48. 4 times, it's going to be 12 times, and 12 times 2 is 24. Then you get 2 and 3 gives you 6 for free. 6 goes into 24 4 times, and 4 times 4 is 16. Great little trick if you're following that. 7, 8. 8 goes into 16 twice. 2 6s are 12. and then 9, 10, 11, 12. I think this is it. Okay, so what's the biggest number that appears in both lists? Oh, excuse me, all three lists. It looks like it's 12. Okay, so the answer is going to be 12. Well, how do I do this mentally? So for greatest common factor, I take the smallest number, because I'm not going to get factors that are common for all these that are bigger than 24. Then I ask, does 24 go into 36? The answer is no. Next factor back from 24 is 12. Does that go into 36? Yeah. Does it go into 96? Well, maybe I go to my calculator for it, excuse me. But I do 96 divided by 12, and I get an integer. So guess what? The answer is 12. Okay. So for prime factors, okay, if I did 24, 36, and 96, okay, that's going to give me 2 and 12. This is going to give me 2 and 6. This will give me 2 and 3. For 36, I'm going to get what? 2 and 18, 2 and 9, 3 and 3. For 96, you get 2 and 48, breaking it up a little differently than I did last time for no reason other than to show you can. 2 and 24, 3 and 8, and then the 8 is going to be 3 2s. Okay, now what's that question this time? So for greatest common factor, you look for the least number that appears of each factor. And if it's 0 of that factor, it means you don't take any. Okay, so I'm looking for my 2's. Here I have 3 2's, here I have 2 2's, and here I have 5 2's. So I guess the 2 2's wins the slow race, wins the small race. It's like golf, you want a lower score here. So it's 2 squared, okay? Then we're looking for what? The least number of 3's. Well, here I have 1 3, here I have 2, and here I have 1. So it's a tie, so it doesn't matter. You take 1 3. 2 squared is 4 times 3 is 12. Okay? So that's pretty much all I have for you. It takes a little practice, okay? But I think it's pretty good stuff. Very easy to get confused with each other because there's certain things in the methods where when you're dealing with the greatest common factor, you got to think of smaller stuff, believe it or not. And when you're thinking of least common multiple, you're often thinking of bigger stuff. Okay? And probably a good idea to leave it. That's a little bit untrue because every number is a multiple and factor of itself. So when I said bigger stuff, it means stuff that's least as big as the given number. When I say smaller stuff, stuff that's no bigger than the given number. Okay? So feel free to practice this. Take your methods, but also you need to be able to recognize which method is better when. Bigger numbers, prime factors is good. Smaller numbers, list and mental method is good. So enjoy, practice, tell a friend. Take care. Take care.